So I think most of you are still confused about meso compounds. So let's just have a quick final look. So this is how you give R and S configuration. So when it is anti-clockwise, you have S, and when you have clockwise, you have R. So I'm pretty much assuming at this point, you know how to assign these configurations. So for the meso compounds, they have chiral centers, but overall they're achiral because they have plan of symmetry. So the rules are they should have at least two chiral centers. It can be more than two. They should have internal plane of symmetry, but sometimes they have a vertex of rotation as well, but this is like an advanced level. At this point we're just gonna call it internal plane of symmetry, and they should be able to superimposed on their mirror images, and this is just a physical property. So this is very important. Meso compound is the property of one compound only, right? In the exam you would see they will give you one more same looking compound but with different conformation. It means different rotation. So you just have to find out if they are same or not. For example, if you look at this compound, so basically this one is a meso compound, right? So this is a property of one compound. This is the same compound but different rotation. We'll know more about it now. So how do I know if the given first compound is a meso? So if a compound and its mirror images, can be made to look exactly the same just as original image through rotation without breaking, because we are allowed to rotate the bones without breaking or changing it, then the compound is meso. Now at this point you would be like, what do you mean by mirror image? What do you mean by rotation? What do you mean by breaking? Okay, I'll tell you, just chill. So let's understand. There are two methods for finding out if apparently same looking compounds are meso or not. First method is mirror image method, that you image, like draw the mirror images and find if it can be superimposed or not. Second is RNS method, and at this level RNS method will work for you, but we'll go through both methods. Okay, but let's understand what do I mean by rotations. My animation would be tripping a little, so just ignore, but hopefully it will make sense. So this is a compound, right? So now we can have three different kind of rotations: vertical, horizontal, across the plane. For vertical and horizontal rotation, the wedge becomes dash, dash becomes wedge. Now what do I mean by that? The compound, vertical, this is called vertical rotation. Like in vertical mirror image, you vertically rotate it. So when you vertically rotate it, it will be like this, right? Now both of these signs will be changed. Now for the horizontal, you just horizontally rotate it. Both of them will be changed. So for the planar, just in the same plane you change it. So nothing is going out, nothing is coming out, it's still same, but you have just shifted the plane. So you would say the wedges will still be wedges. Okay, now if you don't understand it, look at this example. So you can just pause it for a moment and try to understand it for a better understanding. So now, example, method one. We're going to use the mirror image and rotation method. So this is a compound and this is the other compound. We have to find a relation between them. For it to be a meso compound, there is a plane of symmetry. For a plane of symmetry, it is very obvious that it looks like a butterfly, like it can be folded, this half can be folded on this half like a butterfly, but we have to verify it, right? So now for this one, I'm going to draw its rotations. Remember, you can draw the rotation, it will still be the same compound, it is allowed. So remember this rotation, the vertical rotation? Remember this rotation, the horizontal one? Remember this rotation, the planar one? So you see, one of the rotation is exactly the same as the given compound. So it means this compound is basically the same as this one, but with different rotation. So these are meso compounds. Basically, it itself is called a meso compound, but these two are same as well, because this one is just a rotation of this one. Okay, moving on. The R and S method. My animations are tripping, but you will bear with me. So if there are same looking compounds and both have chiral centers, with different configurations, RNS, it will have a plane of symmetry and it will be a meso compound, and the other compound with the same group should have different RNS, both of them will be identical. I know it's too much worse, right? Let's try to imagine it. Okay, this is the compound, right? The same one. So now if you do the maths, like this one is R, this one is S. So that's what I said. Both cryogenic centers, chiral center and styrogenic centers should have different configuration. This is applicable if they look kind of same, because you know, if you look at it, both chiral have the same kind of geometry on the both sides, right? So RNS, so it means it has a plane of symmetry. Now if the opposite image, if you see, if the elements are in the same place, like OS same place, OS same place, but it has different configuration, SNR. So it means these are same. These are meso compounds, identical. Let's try to verify it a little bit more in this case. Okay, this is the main compound, right? So apparently it's the same as the previous one, because this one is R, this is S. We can draw a plane of symmetry. So this one is a meso compound. But what about this one? So now we have already drawn 3 rotations of this one, and none of the rotations look like this one. So this is for sure, these two are not same compounds, right? So now if you can use the RNS method, you would see if all configurations are changed, all R's become S and all S becomes R, you have enantiomers. But if only one changes, you have diastereomer. So how many are changing here? R stays R, but this one becomes R. So if only one is changing, so this should be a diastereomer. So for this one, you don't have to draw. If the compounds are in the same position but different wedge and different dash, you just opposite it. You just reverse it. Okay, how about this one? Apparently, you can draw a plane here, like diagonal plane, and you would see this might be a plane of symmetry, but in reality, it's not. It doesn't have a plane of symmetry. Why? Because these both are SS. For it to have a plane of symmetry, it has to be opposite. So definitely it's not a meso compound. It doesn't have a plane of symmetry. But what's the relation with this one? Let's find out. So this is R, this is R. So in this case, if you see, both have changed. So when both are changed, what would it be? Enantiomers. Very good, well done. Okay, now how about this one? Now closely, if you look at this compound, let's look at this one first. Can you draw a plane of symmetry here? Does it look like a butterfly? Can you just fold this one over here? You cannot, right? But let's say we are allowed to do it. Sometimes symmetry is not visible, so what we do, I'll pinch this half and rotate it, so that CL will be on the same side and this one will come here. But if I rotate it, both wedge and dash will be opposite. Now CL is dash here. If I rotate it, it becomes, sorry, CL is wedge here. If I rotate it, it becomes dash. So this one is not same. So if this is not same, according to the rotation rule, it cannot be a meso compound. And also R and S shows both are R, right? So it cannot be a meso compound. But if you look at the other compound, R becomes S, R becomes S, so they're supposed to be enantiomers. Okay, how about this one? Okay, now look at C1 and this one, right? Now if you look at it, it's very hard to find a plane of symmetry. You cannot like just flip it like a butterfly. But we are allowed to rotate sometime when symmetry is not visible. I'll pinch this, move it. So if I move it, your chlorine is dash here. When rotated above, it will become a wedge. So it will become same. Cl and H become same, so I can do it like a butterfly, right? And if I try to verify by RNS rule, so see both CC, same looking, to verify for RNS, you have to make sure that both chiral centers should have same type of atoms, right? Don't try to match apple with bananas. So see RNS. So this is a plane of symmetry and it is going to be a meso compound. And obviously there's a plane of symmetry and this other compound with the same type of atoms with the opposite configuration. So these are identical. Okay, these are the same yapping. I'll give you the PPT. But at this moment, you might be thinking, sir, ask you guys to make your presentation pretty, put memes, but my presentation looks so ugly because I just made it in 5 minutes, okay? So give me a benefit of doubt. Okay, how about this one? Okay, this is a compound, right? You can draw a diagonal plane of symmetry here, right? So this one is R, this is S for on both. This one is not chiral center, by the way, only this one and this one. So this is R, this is S, okay, there is a plane of symmetry and opposite image, same arrangement but different configuration. So yeah, same compound, and this one is a meso compound. So what I want you to do, I want you to do exercise and try to verify the same thing by rotation method. So I hope you guys are pro in meso compounds now.